Hello guys, welcome to Vision E-Tech. In the previous session, we had discussed about classes and objects, right? Just recall what are classes and what are objects. Class is a blueprint or a template to create an object. If you want to create any object, you need a class first. An object is an instance of class. It is nothing but it describes the class. It describes the state and behavior of a class. State and behavior is nothing but data and functionality of a class. Main class should be declared only once. An object can be created many times. Class doesn't allocate any kind of memory because while creating class, you just use only class keyword. You doesn't assign any kind of variables. So it doesn't allocate any memory. An object allocates memory when it was created. If you want to create any object means you want to assign a variable. You are assigning the variable means what it will be happening. All the methods, functions, what are written in the class that will be stored in that variable, right? Then only you can call those methods, functions by using this variable. So you are assigning a variable here. That's why it allocates some memory when the object was created. And class is a logical entity and object is a physical entity. Class can be created by using class keyword and object can be created by using new keyword. Not only a new keyword, object can be created by using 5 ways that are new instance method, factory method, clone method, and deserialization. These are the 5 ways to create an object. Okay, these are nothing but classes and objects. Let's move to our today's concept, variables and data types. Variable is a container to store the data. Whatever the information that you have given, that will be stored in one container. Here container is nothing but variable. The information will be stored in a variable. A variable is assigned with a data type. See here the syntax, data type, variable name is equal to variable value. Int a is equal to 2. Here int is nothing but data type and a is nothing but variable name and 2 is a stored value in variable a. Here 2 is stored in a variable a and this variable a is in the form of integer. And this 2 will be stored in certain memory. And these are the types of the variables: local variables, instance variables, and static variables. Local variables. If variable is declared inside the body of the method or a block, it is called as local variables. You can use this variable only within the method or a block. Other method doesn't know about this variable. And instance variables. If variable is declared inside the class but outside the body of the method is known as instance variables. It will be declared inside the class but outside the body of the method. It is called a instance variables. And next, static variables. If the variable is declared as static, then it is called as a static variable. You can create a single copy of the static variable and share it among all the instances of a class. You can create a static variable once and can use multiple times. Let's see the example. You people will get the clarity about local variables, static variables, and instance variables. Go to Eclipse. Now I'm creating another class. Here my class name is variables. Okay. Here my class is created. Local variable means you can declare this variable only within a method or a block. These are nothing but local variables, right? Now I'm creating a method public void display. This is my method. Inside this method, I'm declaring a variable. A is equal to 100. Okay? Inside this method, I'm printing a value. Now what I want to do? I want to call this display method by creating object. Variables. By using new keyword, you can create an object. Okay? Now I'm calling my display method. Display. Now what will be the output? 100 is my output. Okay, see 100. 100 was displayed. See here, I had declared int a is equal to 100. 100 will be stored in the variable a. Okay? First, suppose I'm creating another method, public void display 1. Okay, this is my second method. Inside this method, I want to call a variable. Will it possible? Will it possible to call a variable here? Once check. Now I am calling a variable. See, it was showing error because display 1 doesn't know what the variable you are declaring above, what the variable you are declaring in above method. So it was showing error. See here, it was showing create a local variable a. I had already created, but it was showing means I want to create local variable a in the method display 1. Okay. See here, in b is equal to 200. Okay. Now I'm printing b. I'm calling here display 1 method. It will display. When display 200. See here 200 was displayed. Means int a is equal to 100 is a local variable of method display. Okay. Here int b is equal to 200 is a local variable of method display 1. Right? Now instance variable is nothing but it will be declared inside the class but outside the body of a method. Okay. Now I'm declaring the variables int x is equals to 120. Okay, inside the class, I'm declaring the variable x as 120. Okay, now I'm calling x. See here, it was showing error because I doesn't declare any variable here. Here means inside the main method, I didn't declare any variable. That's why it was showing error. Inside the class, I declared. See now I am declaring my object variable var.x. Means object will be associate the instance variable. Okay. Now save it and run. See here 120 was displayed. Now what happened here? Inside the class I had declared the variable. Outside the body of the method, I am calling my variable which was written inside the class. Right? Here int is equal to 120 is nothing but instance variable. Okay. Now static variables. Static variable can also declared inside the class but outside the method by using static keyword. Static int y is equal to 150. Okay. Now here inside the class I have declared int y is equals to 150 by using static keyword. It is nothing but static variable. I am calling my static variable. Object will not associate here because you can use static variable anywhere. Save it and then it was displaying 150. Okay. See, I can display static variable anywhere. See. Now I'm calling here. It will display as 150 here, right? In a method display one also, I can call my static variable. You can create a single copy of static variable like static in y is equal to 150 and can share among all instances of class. I'm calling static variable inside the display method and also in display one method. I can call it on anywhere. Okay? Nothing but static variable. See here, local variables can be declared inside the method and inside the block. Other methods doesn't know about this variable. Instance variable is nothing but it will be declared inside the class but outside the body of the method, and object will be associated the instance variable like var.x. Without associating object, we cannot declare the instance variable. And static variable is also nothing but we can create static variable inside the class but outside the method by using static keyword. Okay. You can create a single copy and can share among all instances of class. These are nothing but instance variable, static variable, and local variables. I hope now you people got clarity on local variable, instance variable, and static variable. Let's move to our next concept, data types. It specifies different sizes and values that can be stored in variable. If you want to create any variable means you want to assign certain data type to that variable. If someone asks you how many data types are there in Java means you just say there are two types that are primitive data types and non-primitive data types. Here primitive contains Boolean and numeric. Boolean contains the Boolean data type. It stores in two ways that are true or false. And the size of the boolean is one bit of information. Numeric contains character and integral. Here character means it is used to store the characters. Like it is used to store the letters. It has a char data type and it has 2 bytes of memory. 2 bytes means it stores 16 bit of information. An integral. Integral means it's a number format. Integral contains integer and floating point number. Integer means it's a numerical value. Floating point means it's a decimal value. It accepts only decimal value. Integer has byte, short, int, and long data types. Here byte has 1 byte of memory and short has 2 bytes of memory. Int has 4 bytes of memory and long has 8 bytes of memory. Floating point accepts only the decimal values. It contains float and double data type. Float has 4 bytes of memory and double has 8 bytes of memory. See the order here. First is byte, byte with 1 byte of memory. And short, short has 2 bytes. Next is char, char has 2 bytes. We can store the character by assigning number for each, like character is a single 16-bit Unicode character. We can store the characters by assigning numbers for each. And next is int with 4 bytes. Long has 8 bytes and float has 4 bytes and double has 8 bytes. This is the order of the data type from lower data type to higher data type. See the representation of each data types here. Int x is equal to 10 means 10 was storing in a variable x. X is an integer format. And this is the range of the integer. Here long L is equal to certain value that is ending with L. Ending with L means it is a long value. Long is used when you need range of values more than int means then use long. Byte A is equals to 10. Byte is used to save the memory in large arrays like byte is 4 times smaller than int. And next is short. Short is equal to certain number. This was the range of the short. And char C is equals to B. Here B is nothing but it's a character. It's a letter. We can also assign number for each. Means char is a 16-bit Unicode character. See the examples later, you people will get the clarity about this. Like boolean b is equal to true. Here, boolean stores only two values that are true or false. It is float. Here, range value of float and double is unlimited. If you need to save the memory in large arrays, then use float. It is a certain number ending with year. It is nothing but float. Double means it used for decimal values just like float. Let's see the difference between float and double. Yes, float occupies 4 bytes of memory and double occupies 8 bytes of memory. Accuracy of float is low and double is high. Float follows single precision and double follows double precision. Here, by using float, it is mandatory to use f as suffix. Like we want to use f at the end of the number, like 8.33f. Actually, f means it is a float value. It is not mandatory to use d as suffix. Means if you are mentioning a double value, it is not mandatory to use d as suffix. Let's see what is single precision and what is double precision. It is a float is a IEEE 754 floating point standard. It follows single precision. IEEE 754 means it is used for representing floating points in numbers. Means it defines the format for 32-bit and 64-bit memory. It specifies how the bits are allocated. See here, there are sign, exponent, and mantisan. This is nothing but significance. These are the components of IEEE 754 floating point format. Sign means it represents the sign of the number. Means one means it's a negative and 0 means it's a positive. Exponent means it represents exponent of floating point numbers. This allows very small and very large values. It contains 8 bits here in 32-bit of memory. Significance means it holds the fraction part of floating point number. Here 338.33 is there. This fractional point will be stored in this significance. And in the same way, double also contains sign, exponent, and significance. In double, it contains 64 bits, means 8 bytes. Okay? And these are the differences between float and double. So remember, this is the frequently asked question for the freshers. What are differences between float and double? And next is typecasting. Typecasting means it converts a value from one data type to another data type, both manually and automatically. There are two types of typecasting. One is widening. Widening typecasting means it converts lower data type to higher data type. Here the lower data type is byte and higher data type is double. We can convert lower data type to higher data type. Automatically the compiler will convert here. Don't want to write anything. During widening typecasting, see here, byte will convert to short, short will convert to char, char to int to long, and long to float, float to double. This is the order from lower to higher. This widening typecasting will done automatically by the compiler. And next is narrowing typecasting. It will convert higher data type to lower data type. Means it will convert double to float, float to long, long to int to char, and char to short, and short to byte. This narrowing typecasting will manually done by the programmer. If it doesn't perform any typecasting, then compiler will generate compile type error. Okay. This is the narrowing typecasting and widening typecasting. Let's see the examples. Now I'm creating another class. That is data types. Okay, now data types class is created. Now here I'm declaring variable a as int. I'm storing a value 10. Now I'm printing this here. It will display 10, right? Yes, it will display 10. Now next one is by. See by b is equals to 100. I'm storing 100 value in B variable. Now I'm printing it. Now 100 will display. But if I give 150 here, it was showing error because the range of the byte is minus 127 to 128. That's why it was showing error. Up to 127, we can store the values. Okay. Next is Boolean. Boolean contains only true or false values. That is true. Here I am declaring true. It displays true value. Okay. Next one is short. Showed S is equals to 10,000. Then now it will display 10,000 as short value. Next data type is cat. Cat C equal to, it contains letters. So character values will be written in a single quotes. Now I am calling C variable. It will show output as B. Character is a 16-bit Unicode. If I give any value like any number, if I assign any number like 98, it will show the Unicode value of 98. Just see the output. The 98 contains the value B. This is the Unicode of 98. That's why it was showing the output as B. Okay. Next is float. Float F is equals to 12.44. Okay, now at the end of the number, you want to use F. Means it will declare it as floating point number. If you doesn't declare anything like here F, it will show you error. See, now the error is gone because this now this number belongs to floating point number. Now it will print that number. See, 12.44. It was displayed. Now coming to double. It is not mandatory to use D as suffix here. Just see. See, it was stored. It doesn't show any other because it is not mandatory to use D as suffix. Okay? Let's say. Just save it and run. See, it was displayed. 233.22 belongs to double data type. Next is long. Long L is equals to, if I indicate any number like this long number, see, it was showing error because it's not an integer because the range was crossed here. So it was showing errors. See, the error type int is out of range. Okay, this is out of range. So it was showing error. If I indicate L as suffix, this number belongs to long data type. Now the error is gone. So you want to indicate L as suffix by using long data type. Okay. Now print this. It will print this number. See, the long number was displayed here. We had also discussed about another topic, right? That is typecasting. Typecasting means one data type will be converted into another data type. It is nothing but typecasting. Conversion of lower data type into higher data type is nothing but widening typecasting. It is also known as implicit typecasting. Okay, then see here. So remember the order of the data types from lower to higher. First is byte. And next one is short. And next is int. After int, long, then float, and double. This order is based on sizes of the data types. See here, byte contains 1 byte of memory and short contains 2 bytes of memory And char contains 2 bytes of memory. It contains 4 bytes of memory. Long contains 8 bytes of memory. And float contains 4 bytes of memory, and it follows single precision based on IEEE 754 floating point. And double contains 8 bytes of memory, and it follows double precision with IEEE 754 floating point standards. So, this order is based on sizes of the data types. Okay. Now I want to convert the lower data type to higher data type. This conversion will happen automatically. And this is called widening typecast. Okay. Remember, widening typecasting means it converts lower data type to higher data type. That means byte will convert to short, byte will convert to char, and byte will convert to int. Int will convert to long, long will convert to float. Okay? The lower data type will convert into higher data type. That is nothing but widening typecasting. It will be done automatically. Just see, I am declaring variable in x is equals to 30. Okay? Now I want to make it as float. Okay? Float f1 is equals to x. Here, inside the float, I am declaring x variable. Now, the integer want to become floating point number. That means that integer want to become a decimal value. Like guess the output. Now, I am printing by decimal value. Means floating point value. F1. What will be the output? Output will be 30.0 because float means it displays in a decimal format. Save it and run. Observe the output. 30.0 is an output. Int was converted into float here. In the same way, we can convert long to double. We can convert float to double. We can also convert short to float. Like that, we can convert lower data type into higher data type. That is nothing but widening typecasting. Narrowing typecasting is nothing but it will convert higher data type to lower data type. Means double will convert to float, float to long, long to int to char, char to short, and short to byte. This is the process of narrowing typecasting. It is also known as explicit typecasting. It doesn't convert automatically. We want to allocate any casting to this. If it doesn't perform casting here, then the compiler will generate compile time error. Now see, I'm giving float f2 is equals to f. Okay, this is my floating point number. Now I want to convert it to int. Means integer means we doesn't need decimal values here. Okay. See, int y is equals to, if I give like this, int y is equals to f2 means it will show error. See, it was showing error here. It was showing add cast to int because I want to mention this as int. Here I want to ask that I want a conversion from float to int. So I want to mention here int. Okay. Without mentioning, we will get compile time error. Okay. Now I am printing my int value. Okay. Now what will be the output? The output will be 344. The decimal points will get lost because integer contains only numerical value. It doesn't contain any decimal values. Okay. Now save it and run. See the output 344. Point values had gone. Okay. This is nothing but narrowing typecasting. I hope now you people got the clarity about typecasting. Widening is nothing but the conversion of lower data type to higher data type. It will perform automatically by the compiler. Narrowing typecasting means higher data type to lower data type. We want to perform, the programmer want to perform the narrowing typecasting. If it doesn't perform any casting here means we will get the compile time error. In this session, we had studied about variables, types of variables, data types of data types, and typecasting. Up to now, we had completed introduction, installation and setup, classes and objects, variables and data types. And the below concepts will be discussed in further sessions. Thank you.